Hello and welcome to Otten Math. In this edition we're going to talk about problems involved in finding equations of lines. In the first problem we're asked to find the equation of a line whose intercepts are twice those of the graph of 2x plus 5y is equal to 10. So the first thing that we want to do is we want to rewrite the equation in slope-intercept form to find out the y-intercept. So the x-intercept, first of all, is where y is equal to 0. So we can figure out the x-intercept as 10, 0. So I have 2x plus 5 times 0 is equal to 10. X is equal to 5. So 5, 0 is going to be my x-intercept. 10, 0 now needs to be my intercept for the equation of the line whose intercepts are twice those of the graph. Next we want to find the y-intercept. And we find out where where x is equal to 0. So we substitute in 0 for x. I get 2 times 0 plus 5y is equal to 10. Y is equal to 2 in this case for this equation. And for the line whose intercepts are twice those of the graph, we find out that the equation is 0, 4. So we have 2 points, 10, 0 and 0, 4. We can figure out the slope of those 2 points, and we'll call 10, 0a and 0, 4b. The slope of AB is going to be 0 minus 4 over 10 minus 0, or negative 4 over 10, or negative 2/5. Then we can plug in our values of the y-intercept and the slope into the slope-intercept form to figure out the equation. So y is equal to mx plus b, where the slope is negative 2/5, as we've learned here, and the y-intercept is going to be 4, as we've learned in the second part of this problem. So y is equal to negative 2/5 x plus 4 is the answer to our question. In the next problem, we have a line that has a y-intercept of 2 and forms a 60-degree angle with the x-axis. And we want to find the equation of the two possible lines. So in this case, we have a 60-degree angle with a blue line with a y-intercept of 2. In the second case, we have a 60-degree angle with a y-intercept of 2. The blue line is going to have a negative slope, and the red line is going to have a positive slope. Well, we know that the change, or the slope, is going to be the change in y over the change in x. It's pretty easy to find out the change in y. We know the change in y is going to be 2. We want to find out what the change in x is. So we want to find out what this value is. So we know that x times root 3 is equal to 2, because as our special families say, the side that's opposite the 30-degree angle is x, and x root 3 is the side that's opposite the 60-degree angle. We know the side that's opposite the 60-degree angle is 2, so we know x root 3 is equal to 2. So let's solve for x. We get x is equal to 2 over root 3. And remember, we can't have a radical in the denominator, so we multiply both the numerator and denominator by root 3. And then we end up with 2 root 3 over 3. So now we have our x change from 0 to 2 root 3 over 3, which is the same as 2 over 1 times 3 over 2 root 3. Now we end up with the same problem we had before. We have a radical in the denominator. But before we go, we rationalize the denominator. Let's simplify this problem. So I have 2, the 2's cancel to 1, and I'm left with 3 over root 3. I again multiply by root 3 over root 3 to rationalize, and I'm left with 3 root 3 over 3, or just root 3. So I know my slope is going to be root 3 when it's positive, and it's going to be negative root 3 when it's a negative slope. I know my y-intercept, so I have y is equal to plus or minus root 3 x plus 2 as my y-intercept. In the next problem, we're asked to find the point of intersection of the medians of triangle ABC. Well, the first thing we need to do is find by definition, the medians are the center points of the two sides of the triangle. We find the medians because they're half the distance from A to C. So 2 minus 0 divided by 2 gives me a value of 1. 6 minus 0 divided by 2 gives me a value of 3. So 1, 3 is my midpoint of the segment AC. The midpoint of my segment BC is 4 plus 2 divided by 3, and 6 plus 0 divided by 3. So my midpoint is going to be 3, 3. So now I want to find the point of intersection of the medians of the triangle. Then I have also my line from 2, 6 to, and this point is going to be 2, 2. But I know that the equation for that line is just x is equal to 2. So the median from C to AB is going to be x is equal to 2. The median from A to CB is going to be y is equal to x, because I change the same amount for y as I do for x. I go from 0, 0 to 3, 3. My y-intercept is 0. So my line is just y is equal to x. And the median from B to AC is y minus 0. So I have a value of 0 for y1 is equal to minus 1, because the slope is going to be negative 1, times x minus x1, which is 4, which leaves me with y is equal to negative x plus 4. Now I have to solve for all of those values. X is equal to 2, y is equal to x. If y is equal to x, when x is equal to 2, y is equal to 2. That means that my point is going to be 2, 2. In the last problem, I'm going to find the equation of the reflection of the graph of y is equal to 3x minus 1 over several values. First, over the x-axis. When I reflect it over the x-axis, I'm just changing the slope from positive to a negative slope. So my equation is y is equal to negative 3/4 x. In my next problem, I'm reflecting over the y-axis. Now my slope changes as well. It becomes negative. But my y-intercept stays the same. So I'm left with y is equal to negative 3/4 x minus 1. In my last equation, I'm asked to find the reflection of the graph over the line y is equal to x. Whenever I reflect something over y is equal to x, I just change the x and y values and then solve for y. So in this case, I rewrite the equation as x is equal to 3/4 y minus 1. Now I solve for y. I add 1 to both sides. I have 3/4 y is equal to x plus 1. I divide both sides by 3/4, or in fact multiply by 4/3, and I end up with y is equal to 4/3 x plus 4/3.